Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is Nur Adlin binti Rahiman. Today I would like to present about physics and aerodynamics. The first topic is properties of light. Light travel in straight line. Light travel around 300,000 km per second. The speed of light is 300 million meter per second. The electromagnetic spectrum. These are some examples of electromagnetic spectrum. Dispersion of light. Light spectrum, there are 6 colors readily identified: red, orange, yellow, blue, and violet indigo. When light passes from one medium to another, it is refracted. When white light passes through a prism, it is refracted twice, with red the least and violet refracted most. Separation of white light, this manner the color of spectrum called dispersion. Color combination. Objects appear colored because surface will absorb some of frequencies and reflect others. A red filter, for example, will only allow light with the longer wavelengths associated with color red to pass through. Red, green, and blue, known as light primary colors as they cannot be created. Secondary colors can be created by mixing two primary colors. Reflection of light. Reflection change in direction of a light wave when it bounces off a boundary. There are two laws of reflection. The angle of incidence I is equal to angle of reflection R, and the reflected ray lies in the same plane as the incident ray and normal at the point of incidence. Concave mirror. Concave mirror is converging mirror due to ability to convert light. Application of concave mirror. First, reflector, co-head light and torchlight. Second, magnified mirror, mean dentist mirror. Convex mirror. Convex mirror is diverging mirror due to ability to diverge light. Application of convex mirror. Blind corner mirror mean to widen the field of view. Curved mirror. Principal line axis P equal to line passing the center. Center of curvature C mean the center of the mirror. Principal focus F, midway between point P and C. Radius of curvature R, distance between P and C. Focal length F is equal to distance between P to focal point. R equal to double F. Refraction of light. Change in direction of the light ray occurs when light ray move from one medium to another. Example, air to water. Direction of refracted depends upon whether they move into more dense or less dense medium and respectively slow down or speed up. The rays of light bend towards the normal when enters and optically. The ray of light bends away from the normal as it enters an optically less dense medium. Example, as it moves from glass to air. Law of refractions. The incidence ray, refracted ray, and normal lie in the same plane. The ratio is a constant when I is the angle of incidence and R is the angle of refraction. Critical angle. When the angle of refraction is 90 degrees, the angle of incidence is known as the critical angle. The image shows the example of the critical angle. Total internal reflection. When the angle of incidence I accepts the critical angle C, the total internal reflection occurs. The image shows how the incident I accepts the critical angle C. Lenses. There are two basic lenses. First, convex lens, or known as a converging lens, and other one is concave lens, or known as diverging lens. Ray parallel. to the principal axis, which reflected through focal F. Third, optical center O is the center point of the lens. Fourth, the calculating of power equal to 1 over F. Wave, motion, and sound. Transverse wave. Particles of the medium are displaced in a direction perpendicular to the direction of energy transport. Particles do not move along with wave, simply oscillate up and down. It picks a single particle and observes its motion. Longitudinal wave. In longitudinal wave, particles of the medium are displaced in direction parallel to energy transport. Particles do not move down with wave, simply oscillate back and forth their individual equilibrium position. Wave is seen as the motion of compressed region which move from left to the right. Water wave. Water waves are examples of waves that involve a combination of both longitudinal and transverse motion. As waves travel through water, the particle travels in clockwise circle. Radius of circle decrease and depth of water increase. The particle in the blue color as it indeed travel in clockwise direction. The image shows the blue color travels in clockwise direction. Wave characteristic. Wave length means the distance between two crests. Frequency, the number crests pass a point every second. If one crest goes every second, then the frequency is 1 cycle per second or 1 Hz. Amplitude, the height of the wave crest above the undisturbed position. Fourth, velocity, the speed and direction that the wave crest itself is moving. Interference wave. Interference or superposition occurs at points where two or more waves meet. At this point, combination of waves produce either larger or smaller waves or even cancel each out. There are two types of common interference. First, contractive interference, where two waves having different amplitude. The superposition of two waves produces increase in disturbance and form with greater amplitude. Second, destructive interference, where two waves having different amplitude and the second wave perfectly out of phase with first. When combined, effect is reduced the amplitude of first wave. Standing wave. Standing or stationary wave occur in wire that tightly threaded between 2 points. These wires are plugged or caused to vibrate. Transverse wave travels to the ends and reflected backs. The waves cross each other in their travel backwards. Standing wave patterns are characterized by certain fixed points along the medium which undergo no displacements. Midway between every consecutive nodal point are points which undergo maximum displacement. This point calls antinodes. Sounds. Sound is energy and is produced when object vibrates, causing the surrounding air particle to vibrate. Sound travels through air or medium in the form of longitudinal wave. Sound wave, also called acoustic wave, high and low pressure known as compression and rarefaction. Speed of sound. The speed at which mechanical vibration sound travel in elastic medium varies with temperature and altitude. Sound speed at sea level is considered through 340 meters per second at 15 degrees. Sound intensity. Its noise, resonance, and vibrations. Longitudinal pressure wave within elastic medium, such as air, water, or solid material. Sound travel faster in solid rather than air. Frequency. The number of vibrations completed per second. F equal to 1 over T, where T equal to time in second. Unit Hertz. Higher the sound, the higher the pitch. Sound propagation, transmission and reception of sound. Source, medium, detector. Range of human can hear 20 to 20,000 Hz. Doppler effects. The apparent raise is the pitch or frequency of a sound as its source approaches the hearer and the decrease in pitch as the source moves away. Sound vibration. Cause waves which radiate out from their source at the speed of sound. Aircraft move less than speed of sound. The sound moves ahead of the aircraft. Aircraft flies at the speed of sound produces shock wave. And the last one is resonance. The natural frequency of a given object vibrates naturally or without the external force. Two objects have similar frequency. If one vibrates, the other one can move too. It also deductive force. Okay, that's all. Thank you for watching.